In the previous video, we talked about writing formulas for our ionic compounds. Now we want to talk about naming them. Our rules for naming ionic compounds is you want to write the ion name without the word ion. So for simple ionic compounds, okay, metal with a nonmetal, not a transition metal, so not from group B. If we had NaCl, that was one of the first examples we looked at. This is sodium chloride. Li2S. Li is a +1, sulfur is a 2 negative, so Li2S. This is lithium sulfide. Or MgO, this is magnesium oxide. All right, pretty straightforward for ionic compounds. One of the tricks comes when you have a transition metal. Okay, transition metals can have multiple charges or different charges, so we have to reflect that in the name. So for our ionic compounds with transition metals, we have to indicate the charge on the transition metal by using a Roman numeral. So again, our transition metals, these are group B, and tin and lead. So Sn and Pb. So if we look at two examples, we wrote down a couple compounds earlier. We had FeO and we had Fe2O3. And we knew this first one came from Fe2 plus and O2 minus. Down here we had Fe3 plus and O2 minus. If we followed our rules from just before with regular ionic compounds, we'd call this iron oxide, and we'd call this iron oxide. But they come from two different ions, so the chemistry here is completely different. So we need to reflect that these are two different types of irons in these compounds. Okay, so our name stays the same. We still keep that basic iron oxide and iron oxide. We just indicate this charge on the transition metal with Roman numerals. So the charge here is 2 plus, so we'll put a 2 for our Roman numeral. Our charge here is 3 plus, so we have iron 3 oxide. So that is where those come from. Okay, notice that these Roman numerals have nothing to do with the formula here. Okay, these Roman numerals tell you what the charge is here, which you know what the charge on oxygen is, so you can then get your formula. Try this one out as an example. So we have COCl3. To figure out our charge on cobalt here, CO is cobalt, we can do a reverse charge, reverse cross charge, where our number here, which is essentially a 1 when it's not included, goes as the exponent, or as the charge for our chloride ion. The 3 goes to cobalt. So we end up with cobalt 3 plus, chlorine 3 minus. We have to, or negative, excuse me. We have to make sure that this charge is correct. okay, that we don't need to multiply this by any ratio. This takes on a -1 charge, so this value is correct. So we end up with cobalt 3 chloride. All right, the exceptions to this, okay, we have 3 transition metals that only do 1 charge. They don't do multiple charges. And that is zinc is always a 2+, so it's just zinc. That's its name. It doesn't need a Roman numeral 2. Silver is always a +1. And cadmium, Cd, is 2+. All right. When we name ionic compounds with polyatomic ions, okay, see table 2.3 for more examples. Same rules apply. We're just naming it with the ion names without the word ion. So this is the carbonate ion. So with magnesium, this would be magnesium carbonate. We had, say, NH4Cl. This is ammonium chloride. Na3PO4. This would be sodium phosphate. Be careful when you're looking at your, or when you're memorizing your polyatomics, that the number of oxygens is important. So if we have Na3PO3 instead of PO4, this is sodium phosphite. And notice, you'll probably notice a trend that most all of our polyatomics, we have carbonate, phosphate, phosphite here, these have either an ATE ending or an ITE. Anytime you have the IDE ending, this is an individual element. Okay? So if you saw sodium phosphide, this is not a polyatomic, it's just the phosphorus by itself. So we would have Na3P as sodium phosphide. Molecular compounds. Okay, molecular compounds, these are written in their molecular formula. So again, so we could have a 2:2 ratio, we could have a 6:6 ratio, we could have a 2:1 ratio. Varies for everything. Okay, molecular compounds, these are going to be formed from 2 nonmetals. So if your formula starts with a nonmetal, it has to be a molecular compound. Okay. In order to indicate the number of each atom in the formula, we're going to use the Greek prefixes. Which you do need to know all of them. Most of them you've probably known already or you experienced. So 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 hepta, 8 octa, 9 is nona, and 10 is deca. There are ones that go beyond this, but you need to know the first 10. Why these are important is because for our molecular compounds, we can have the same elements in different ratios. So here we have N2O, next one we have NO2. These are two completely different chemicals, so they need different names. So we name them using the first element name, the second one gets the IDE ending, and we include prefixes for what their subscript is. So we have two nitrogens, so 2 goes with di, so we have di-nitrogen. For our second element, there's only one of them, so we have monoxide. Down here, if our first element has a subscript of 1, typically the mono is left off. So we would just say nitrogen. We have 2 oxygens, so we have dioxide. Go ahead and try these out. Try P2S5, H2O, diphosphorus pentoxide. Go ahead and pause the video and I'll have the explanation next. So we have 2 phosphorus and 5 sulfur, so we have di and penta. So we have diphosphorus pentasulfide. Here, I would accept water. Its technical name is dihydrogen monoxide. And we have diphosphorus pentoxide, so we have phosphorus and oxygen. We have 2 phosphorus and 5 oxygen. So we put our Greek prefixes in front of the name. The last name gets the IDE ending, and then the only kind of special case here is mono is left off of the first. Your book goes through talking about the acids, bases, and hydrides naming. Don't worry about this. I'm not going to test on it. I'm not going to require it. We will cover that in 163. About a third of the quarter of 163 is dedicated to acids and bases, so we'll learn the technical names then. For the most part, you're going to pick up on the names of the acids and bases just sheerly by being in a chemistry class. The last section in Chapter 2 talks about organic compounds. Please do look at it, okay, because we are going to use organic compounds now every so often in examples. So do look at it, kind of be aware of some of the names, look at some of the trends there, but I won't test on it, and that's because organic compounds follow their own rules that if you move on to organic chemistry, you will have to learn those rules, and they are much more complicated than a couple, 5, 10, 15-minute videos. So that wraps up Chapter 2. Do lots of practice with naming. You want to make sure you get it so that it is second nature to you, that you don't even have to think about it.